Orientation and mobility classes in special education schools teach visually impaired people the skills required to navigate safely and autonomously in unknown environments. Orientation and mobility instructors rely on different tactile tools, such as raised line maps, small-scale models, or magnet boards. These tools have proved to be efficient for spatial learning in the absence of vision, but possess limitations. For instance, once a tactile map is created, it is not possible to update its content. In the past decades, accessible interactive maps have been developed to address these limitations. Despite this considerable progress, interactive maps developed to date still have many downsides. In this work, we address two issues that are still encountered in many systems. First, most existing accessible interactive maps are limited to map exploration and do not permit users to construct the maps themselves. Second, most existing interactive maps are research prototypes, and only a few interactive maps have been studied and applied in real teaching environments. Both issues are addressed in this project. Our project consisted of two phases. Phase 1 comprised a participatory design phase with 15 low vision and blind people, 3 orientation and mobility instructors, and 4 professionals from a local special education center over a period of 6 months. Phase 2 comprised an international workshop with 22 teachers and orientation and mobility instructors in which we collected qualitative feedback. The prototypes were developed using an existing spatial augmented reality toolkit which was originally designed for sighted people. This toolkit combines a projector, a depth camera, and a color camera, and enables tracking of fingers and objects. We combined this augmented reality toolkit with tactile tools that are already used in orientation and mobility lessons. We added audio output using text-to-speech synthesis. The prototype can be used in exploration mode and in construction mode. In exploration mode, our prototype enables visually impaired students to explore existing maps by combining raised line maps with audio output and projection. Users explore the tactile map with both hands as they are accustomed to. Complementary visual information is projected on the raised line map for the benefit of low vision students. Students can obtain an audio description by simply pointing to a tactile element with one finger and pressing a key on the keyboard.
Frequent Traveler Lounge. No items present. Entrance, Concourse 1. Entrance, Concourse 1.
In construction mode, our prototype enables visually impaired students to construct maps or itineraries themselves by combining magnet boards with audio output and projection. Orientation and mobility instructors developed a step-by-step learning scenario, and our augmented reality prototype follows this scenario to provide instructions to the student. Starting from elements placed by the teacher, the system prompts the student to place a point of interest or a road on the map in relation to these starting elements. The student then places elements on the map, magnets with foam paper for points of interest, and wiki sticks for road elements. The user may verify whether an element is placed correctly using the same interaction as in exploration mode, that is, by pointing to an element and pressing a key to hear an audio description. If the element is not in the right place according to the scenario, then the system provides corrective directions. In the Phase 1 evaluation, we demonstrated experimentally that all students, regardless of visual abilities and gender, were able to successfully use the prototype. Standardized questionnaires showed a high satisfaction, and users were enthusiastic about the interactive map prototype. The results from the user study also allowed us to further improve the prototype. In the presentation of our prototype to the international workshop in Phase 2, we obtained feedback from participants. Overall, participants found the system useful and thought that it would make lectures more fun and engaging. In this work, we've improved interactive maps for visually impaired students by providing both map exploration and map construction, using a participatory methodology that provides strong guarantees of usefulness, and ultimately will contribute to improving the autonomy of visually impaired students.